This PowerPoint is to welcome you to A-Level Chemistry at Chesham Grammar School. My name is Miss Osborne. I am the subject lead for chemistry and I work alongside 4 other teachers to deliver the A-Level Chemistry course. One of those, Dr. Lotta, you will see a little bit later on as we have recorded some videos for you. I'm sure you all have your reasons for wanting to study chemistry. I hope at the top of that list is that you enjoy the subject. I'm sure you're aware it is one of the hardest A-levels, and that's why it's really important that you have a genuine interest in the subject. You may have a particular career path in mind. We have lots of our students go on to study medicine, dentistry, engineering, veterinary sciences. But likewise, we have students who will go on to study English literature and history. The most successful students are those that really enjoy the subject, enjoy problem solving. There's a huge range of careers that are open to you if you study A-level chemistry. Things such as law, things such as finances. The reason there's so many subjects that are open to you is because of the way chemistry trains you to think. It encourages you to think logically and analytically, but also creatively. It's about identifying problems and coming up with creative solutions to those problems. So if you're studying for anything science related or non-science related, chemistry is a really good choice for you. Hopefully from the information that's gone home, you've realised that we study the OCR A-level course as opposed to B. You have 3 A-level exams and you can see the summary of them on this slide. You'll notice the modules go from 1 to 6. Module 1 is the practical based work, and I will talk about that a little bit more in a few minutes' time. Module 2 is what's known as foundations in chemistry. So it looks at atoms, compounds, molecules and equations, the amount of a substance, acid-base reactions, redox reactions, electrons, bonding and structure. So that module very much builds on your GCSE work, which is why it's so important that you have reviewed that work and done the preparation work that we've set for you over the summer. Modules 3 and 5 are inorganic and physical chemistry. So module 3 is looking at the periodic table and periodicity. Groups 2 and 7, qualitative, as in observational analysis, enthalpy changes, reaction rates and equilibrium, although it looks at them from, again, a qualitative point of view. And then module 5 takes this further. It looks at reaction rates and equilibrium from a quantitative point of view, pH and buffers, enthalpy, entropy, free energy, redox and electropotentials, and transition elements. You will have 2 teachers. One teacher will specialise on modules 3 and 5. The other teacher will specialise on modules 4 and 6, and we will share module 2 between us. Modules 4 and 6 are the organic chemistry. So module 4 is the core organic chemistry, looking at basic concepts of organic chemistry, hydrocarbons, alcohols and haloalkanes, organic synthesis and analytical techniques such as infrared spectroscopy and mass spectrometry. And then module 6 takes it even further, looking at aromatic compounds, carbonyl compounds, carboxylic acids and esters, nitrogen compounds, polymers, even more organic synthesis, chromatography, and carbon and proton NMR, which is nuclear magnetic resonance spectroscopy. Practical work, we have PAGs, which is short for practical assessed groups. There are 12 groups of practicals, and we have 3 experiments within each group. You need to have successfully completed at least one of each experiment within a PAG group. So obviously that's 12 practicals in total. We study a lot more than this to give you as many opportunities as possible to develop the skills that you require for the practical endorsement. The practical endorsement is marked independently of your A-level exam, so it doesn't contribute to your A-level grade. It is a pass or fail in addition to your A-level grade. Having said that, the PAGs that you do, you will be examined on in your A-level exams. So you do need to know these experiments, you need to know what you did and why you did it, how to analyse the data, how to evaluate the data, because you have questions based on this on your exam. As I already said, you have 2 teachers for your A-level chemistry course. You have 9 hours of teaching a fortnight in year 12 and 8 hours a fortnight in year 13, and you have an additional ghost lesson in year 13, which is a 1-hour supervised study session, but we wouldn't be teaching you. So we think about year 12 with the 9 hours a fortnight, you would have one teacher for 4 hours within that fortnight and the other teacher for 5 hours within that fortnight. You should already have received the textbook recommendations. Obviously there is one to purchase. There is also the online textbook on Caboodle, which I strongly recommend you use, as it is a very detailed book. To be successful in studying A-level chemistry, you need to be very organised and very proactive in what you do. We do expect you to prepare for each lesson by reading the relevant sections in your textbook, and we have cover sheets, which I'll show you an example of in a minute, to help you to know what to read before a lesson. We don't tend to teach from the textbooks. We expect you to use them as a resource in addition to what we do with you in lessons. Likewise, we don't tend to say, please complete the questions on pages 73 to 74, for example. We would expect you to do those questions in addition to the work that we set you to do. We also encourage you to read the Chemistry Review magazine. It contains a lot of interesting articles that can encourage you to research further, particularly those of you that are going to study for science-related subjects at university. The more you can build up your knowledge base of interesting articles to refer to in your personal statement and in an interview, the better. But also, in addition to these articles, there are specific sections on how to answer different types of A-level exam questions, which are incredibly useful. You do need to make sure your notes are organised, and we do carry out file checks to encourage you to develop good study skills. And as far as your practical work goes, that will be recorded in an exercise book that we keep at school. The reason we keep it at school is it has to be available in case a moderator from OCR wants to look at it. So the only times you're allowed to take that book home is when you are on study leave. The rest of the time it does need to be in school. So if you need to write up an experiment, finish the analysis that you haven't managed to finish in a lesson, then you would need to borrow the book during school hours, complete the work during a study period, and then bring it back to us before the end of the school day. As I mentioned on the previous slide, we provide cover sheets so you know which pages of the textbook you should be reading. So this is a small proportion of one of the topics from Module 2, the Foundations topic. So we can see here in lessons 1 and 2, you will be covering the mole. By the end of that, you should be able to successfully complete specification point A, and the page numbers of the textbook are given there that you should have read before the lesson. We've also got an example here of a homework sheet that you should have completed as well. The specification points are also listed on the cover sheet. So at the end of, for example, lesson 2 in this case, you would be expected to look at that specification point and make sure that you can do everything related to it. If you think I can do 90% of it, but you're not sure on the final 10%, then you need to come and ask for help on that final 10%. It is really important that you make sure you can do every single part of a specification. Chemistry is one of those subjects where if you let something become a little bit of an issue, it can snowball until it becomes a very big issue. So come and ask for help whenever you need it. As I already said, there are 5 of us that teach A-level chemistry. It doesn't matter who you ask for help, as long as you make sure you're being proactive and keeping on top of your learning, your knowledge and understanding. You know that you've been asked to purchase the Head Start to A-level chemistry textbook. It's really important that you do the work from this book to help you prepare for the course in September. The stronger your GCSE knowledge is, the easier you will find the transition to A-level. So it is very important that you have completed all that work from the CGP book and that you bring it with you to your first lesson in September. We've asked you to make notes. We've also asked you to do the questions. Chemistry is very much about application of knowledge, and it's really important that you do the questions so that we can see and that you can see what you know. I'm sure you already know from having studied for GCSEs, the more you do chemistry questions, the better you get at knowing what is being asked of you, knowing what information you should provide. If you find some of these subject areas difficult, that is not an issue. We run a help session every Tuesday lunchtime, which you're welcome to come and get support. So again, it goes back to asking for help when you need it. We don't mind you asking us questions. We don't mind you asking us the same question multiple times. It is more important that you ask the question as many times as you need to until you are sure of your knowledge. In addition to asking questions, reviewing your work is really important. You all know this because you've been learning how to learn for a very long time now, but you do need to constantly review. So for example, if I'm teaching, I visited the work in the introduction, I visited it 10 minutes later, at the end of the lesson, a week later, etc. And you need to do the same things in your studies. So as I was saying, you've got those Head Start questions to do. Likewise, you've been set questions to do on Seneca Learning. Don't just do them once, do them multiple times. That will help you to really reinforce your learning. So if you've made a mistake once, if you've missed out a piece of information once, you're unlikely to miss it out a second time. But if you do it again, it's very unlikely you'll miss it out a third or a fourth time. So constant review is going to be really important to your success in your studies. Final bit of the work we'd like you to do ready for September is a chemistry research project, as obviously chemistry is as much about people as it is about chemicals. We would like 1 male and 1 female chemist studied, please, and again, to encourage good development of study skills and study habits, please make sure you reference where you got your information from in your research project. Right, I've talked a lot about the course, about the structure of the course, about what we expect from you as our students. What I'd like to do now is to look at the kind of things you would be doing in a typical chemistry lesson. So application, as I've already said, is a big part of what we do in chemistry. So you learn information and then you apply that information. That is going to be the most important skill that you have in your exams. The information we've got here is about isomers. So we have different types of isomers in chemistry. We're going to look at structural isomers. They're compounds with the same molecular formula. So for example, C3H8, but the atoms are arranged in a different order. Hence they have a different structural formula, which gives us the name structural isomers. Types of structural isomers. There are chain isomers, positional isomers, and functional group isomers. We're going to be looking at two of those today, chain isomers and positional isomers. So chain isomers are, we alter the length of the carbon chain. So you can see you've got two examples there, butane and 2-methylpropane. So they have the same molecular formula, C4H10, but their chains are different lengths. So butane, 4-carbon chain, 2-methylpropane, the longest chain is 3 carbons. We don't actually need the 2 in this particular case to show us where the methyl group is, because if the methyl was over here on this left hand side or on the right hand side, it would still be a butane chain. So the methyl has to be in the middle to make it different from the butane over here. So methylpropane, so longest chain, and then the branch is put as a prefix to the name. You will spend a lot of time learning how to name molecules in chemistry, but this is obviously just a very quick overview. So what I'd like you to do before you move on to the next slide is please draw and name the isomers of hexane, and to help, there are 5. So hopefully you came up with these 5 options. So we have hexane, 6 carbons in a chain. We've got 2 methyl pentanes. The methyl group over here is attached to carbon number 2 of the 5-carbon chain, as opposed to 3 methyl pentane, where it's attached to carbon number 3, because there's now number 1, number 2, number 3. It doesn't matter whether you number from the left or from the right, as long as you have the lowest numbers possible. So over here, to get the lowest numbers possible, if this is carbon 1, this is carbon number 2. Obviously with the 2 pentane ones, we do need the numbers because 2-methylpentane is different from 3-methylpentane. We can make the chain even shorter. We can make it a 4-carbon chain, so butane chain. We can have a methyl group on carbon number 2 and carbon number 3 to make 2,3-dimethyl. The di is to show there's 2 methyl groups, 2,3-dimethylbutane, and we can have another 4-carbon chain, and the 2 methyl groups are attached to carbon number 2, so 2,2-dimethyl. If I put them over here, it would still be 2,2-dimethyl because I would start numbering the chain. The second type of structural isomer we're going to look at is a position isomer or a positional isomer, and that's where we change the position of a functional group in a molecule. So here we have 2 alcohols, propan-1-ol and propan-2-ol. Propan-1-ol, the OH functional group, the alcohol functional group, is attached to carbon number 1, whereas in propan-2-ol it's attached to carbon number 2. So they're still structural isomers, they have the same molecular formula, but they are altered by the position of their functional group. So before you go on to the next slide, I would like you to identify as many isomers of C4H9OH as you can, and also try naming them. Hopefully you took into account not only the position of the functional group, but also what we were doing earlier about chain isomers to come up with these 4. So we have butan-1-ol with the OH functional group on the end of the 4-carbon chain, and butan-2-ol with the OH attached to carbon number 2. Again, you number the chain from whichever end gives you the lowest numbers possible. So those are our two positional isomers. We also have chain as well as positional isomers. Remember, both types are structural isomers overall. So we have 2-methyl propan 1-ol. So we've made the chain shorter, put the OH on the end, and we've put a branch on the middle carbon, and we also have 2-methyl propan 2-ol. Very well done if you managed to get all of them. So in case you're wondering why are we so concerned about where the OH group is, it does affect the chemistry of the molecules. So alcohols can be classified as primary, secondary or tertiary depending on the OH group and what is attached to the carbon that the OH group is attached to. So primary alcohol over here, the OH is attached to a carbon that is attached to one other carbon and 2 hydrogens. The one example to this is methanol, which has the carbon that the OH group is attached to 3 other hydrogens. In a secondary alcohol, the OH is attached to the carbon that's attached to 2 other carbons. So the R is referring to an alkyl group, so it's something containing carbons and hydrogens, like a methyl or an ethyl. And in tertiary, the OH is attached to a carbon attached to 3 other carbons. This does affect the chemistry, as I already said, and that is why we are concerned about identifying.
Right. We are having a look at the oxidation reactions of alcohols. There are 3 types of alcohols. There's primary, secondary, and there is tertiary. Primary alcohols, when they're oxidized with potassium dichromate acidified, with refluxes, you end up getting the aldehyde. If you keep carrying on oxidizing this, the aldehyde, that turns to a carboxylic acid. Whereas something like a secondary alcohol, that will oxidize to just a ketone. Whereas the main thing to remember here is that tertiary alcohols do not oxidize at all.
Okay.
Right. The first thing to do is you have a pear-shaped flask. This is kept in an ice bath. And into these pear-shaped flask, I'm going to put some anti-bumping granules. So a small amount of anti-bumping granules, just a small amount. This is followed by some potassium dichromate, which is the oxidizing agent. Then this is slowly, I'm going to add some sulfuric acid to this by making sure the temperature does not go above 10 degrees. Now you see the potassium dichromate is orange to start off with. So add a bit more. So this has been in the ice bath for a little until it completely dissolves. So you can just see here that the potassium dichromate here has dissolved. And that is completely dissolved, made a solution. And I want to keep that there until the temperature goes to 10 degrees centigrade. At the moment it's at 20, so I'm going to wait till it goes to 10. The potassium dichromate and the acid mixture has gone down to 8 degrees centigrade, and I'm going to add half a cubic centimetre of ethanol. Half a cubic centimetre of ethanol, and I'm just going to make sure that that is stirred in, just to show you that the dichromate is starting to oxidise the ethanol. The dichromate will start to turn green. You can see that's changing colour. That's changing colour there. I'm going to add a further 0.5 cubic centimetres of ethanol, and make sure that that still stays around about 10 degrees centigrade before I do the next step. Okay. This mixture has now mixed quite well, and you can see the potassium dichromate there has actually turned a green colour. So instead of having your chromate ion +6, it's gone to chromate ion +3. So some of the alcohol there has already been oxidised. Now, I'm going to turn the Bunsen on, and I'm going to set this apparatus up for reflux. This is a Levy condenser which goes on top of that flask. And now, for about 20 minutes, I am just going to warm up the dichromate. So this will start to react. Now, when the alcohol turns to the aldehyde will evaporate, come to the cooler region of the Levy condenser and fall back down again. So I'm going to do this for 20 minutes. Right, stop.
Okay.
Once the alcohol has been refluxed for about 20 minutes, I've allowed this to cool down for a little while. Then I've set this up so I can distill the aldehyde that's come off it. If I do it for longer, I will convert the aldehyde to a carboxylic acid. Now, I've been heating this, I want to heat this for a little while. And once I start to heat this, I'll stop heating now for a minute, the aldehyde will go down this Levy condenser and be collected. This is something that I've already collected, and I'll show you what the aldehyde looks like. This is what it will look like. It has a distinct smell, a distinct aldehyde-like smell. If I've oxidized it for a longer period, I will convert from the aldehyde to the carboxylic acid. Now, a test for an acid is if I take some sodium carbonate, so if you look at this test tube, if I take some sodium carbonate, put it into there, I should see a gas coming off. And you can see there is definitely bubbles there. If I collected the bubbles would be carbon dioxide. And that's a test to show that the alcohol has turned to the aldehyde to the carboxylic acid. Right, stop. So what I've just shown you there is how do you oxidize ethanol to the aldehyde to the carboxylic acid to get ethanoic acid. This is a general scheme, so just to summarise primary, secondary and tertiary alcohols. Here's propan-1-ol. If you oxidize that, you get propanol. If you carry on oxidizing it, you end up with a carboxylic acid. Secondary alcohols, this is propan-2-ol. If you oxidize that, you will get a ketone. Whereas tertiary alcohols do not actually oxidize at all because of the steric hindrance around this OH group. Once you've got your either your aldehyde or ketone, the test for the aldehyde or ketone is two tests. One is using Fehling solution. If it's an aldehyde, you should get from blue to a red precipitate. And there's another test that you can use a tolerance reagent, which you get a silver mirror test. Whereas ketones do not give any change. Whereas if you had a carboxylic acid, you can add universal indicator to look at the pH of what you formed, or you can add some sodium carbonate and test for the carbon dioxide gas, which turns lime water cloudy.
I hope you enjoyed watching Dr. Lotta do that work, and that gave you some idea of the skills you will be developing in your A-level chemistry course. So to summarise, as I already said, chemistry is one of the hardest A-levels, but consistent hard work, being proactive really is the key to success. Constantly reviewing, constantly questioning. Don't be satisfied with superficial level of understanding. Constantly dive deeper. Ask questions all the time, and you will learn and you will be successful. And most importantly, enjoy it. If you don't enjoy the subject, you shouldn't be studying it anyway. We, the chemistry department, all love our subject, and we hope that we can inspire you to do the same. If you have any questions, please feel free to email me. My email address is on this slide, but otherwise I look forward to meeting you in September. And thank you for listening. As I already said at the beginning of this PowerPoint, you are going to see one of our chemistry teachers, Dr. Lotta, in action, and he's going to show you some classic alcohol reactions distinguishing between primary, secondary and tertiary alcohols. So please watch the videos that we have linked for you.